Hi. Okay, today we're going to talk about divisibility rules and factors. All right, so we've done this before. Take a look at the chart that I've made. Okay, the numbers that we're going to look at are numbers that are divisible by 2, 3, 4, 5, 6, 9, and 10. The next thing we're going to look at is the rule that matches each one of these numbers. And then I give you an example of when it is divisible by that number. All right, so let's take a look at number 2. A number is divisible by 2 if it ends in a 2, 4, 6, 8, or 0. An example of that is the number 4068. It's divisible by 2 because it ends in an 8. It has to end in one of those digits. The number 3 is divisible. A number is divisible by the number 3 if, when I add up the digits of that number, it is evenly divided by 3. What do I mean by that? I have no remainder. Okay, so the sum of the digits is divisible by 3. So let's take a look at an example. 567. Well, I add the digits. 5 in the hundreds place, 6 in the tens, and 7 in the ones. And I get the number 18. 5 plus 6 plus 7 is 18. Can I divide 18 evenly by the number 3? Yeah, 6 times. So therefore, 567 is divisible by the number 3. The number 4, even though it's not in any of your work for this lesson, I wanted to put it in here anyhow. The rule for the number 4 is the last 2 digits are divisible by the number 4 of a number. So if I take a look at the number 248, when I'm talking about the last 2 digits, I'm talking about the 4 and the 8. 48, is that divisible by the number 4? Yes, it is. Therefore, that number would be divisible by 4. Ends in, for the digit 5, the rule is it ends in a 5 or a 0. That's a real easy one. So for example, 3005. Yes, that's divisible by 5 because it ends in either a 5 or a 0. The number 6. Now think about your factors. What 2 numbers multiplied to get to 6 other than 1 and 6? Well, it's 2 and 3. So the rule for 6 is real simple. It has to be divisible by both 2 and 3. So again, it's no new rules here. It's just, okay, what's the rule for 2? Is it has to end in a 2, 4, 6, 8, or 0. And the rule for 3 is that the sum of the digits has to be divisible by 3. So if you say yes to both of those, then you say yes, it is divisible by 6. The number 9. 9 is very similar to the number 3. It's the sum of the digits again, but instead of dividing by 3, you're going to divide by 9. Why? Because 3 is a factor of 9. Kind of makes sense. So let's take a look here. I'm going to go back to number 6, 912. Well, it's divisible by 2 because it ends in a 2. And when I add up the digits, 9 plus 1 is 10 plus 2 is 12, and 12 is divisible by 3. All right, it's 4 times, so it is divisible by 2, it is divisible by 3, so it is divisible by 6. 9, okay, 3,456. Is that divisible by 9? Add the digits. 3 plus 4 plus 5 plus 6 is 18. 18 is evenly divisible by 9, so that number is divisible by 9. You don't want to waste your time. That's what this is like, shortcut. Should I even bother trying the 9? Should I bother trying the 3? And finally, it doesn't get much easier than this one, 10. A number is divisible by 10 if it ends in a 0. Very simple, looking at the ones place. Is it a 0, yes or no? So that number 6,850 is divisible by 10 because it ends in a 0. Not difficult, just a lot of notes. All right, so let's take a look at example 1. Is the first number divisible by the second? So letter A, 567, is it divisible by 2? Well, the rule for 2 was, does it end in a 2, 4, 6, 8, or 0? Oh, wrong place there. And no, it doesn't, so it's not divisible. Letter B, 1015, is it divisible by 5? Well, the rule for 5 was, does it end in a 5 or a 0? Yes, that number is divisible by 5. And letter C, 111,120 by 10. The rule for 10 was, does it end in a 0? Yes, it does. Okay, simple. Try these. Number 1, 160 by 5. The rule for 5 is, ends in a 5 or a 0. Yes. Number 2, 56 by 10. The rule for 10 was, ends in a 0. No, it doesn't. 53 by 2. The rule for 2 was ends in a 2, 4, 6, 8, or 0. And number 4, 1,118 by 2. Does it end in a 2, 4, 6, 8, or 0? Yes. All right, so now all you're doing is looking for the digits 5, 10, or 2. You're just looking at the ones place. And notice a number can be divisible by 10 and 2 because 2, 4, 6, 8, or 0. So it's not just one number. Example 2, is the first number again divisible by the second? Now I'm looking for divisibility by 3 or 9. So 123 by 3, well, let's add the digits. 1 plus 2 plus 3 is 6. Yes, I can divide 6 by 3 evenly. It goes in 2 times. So yes, this number is divisible by 3. Letter B, 1,015 by 9. Well, let's add the digits. Well, that should be a no. 1 plus 0 plus 1 plus 5 is 7. 7 is not divisible by 9. Okay? So let's try a couple. 64 by 9. Well, the rule here is to add the digits. So 6 plus 4 is 10. I can't divide 10 by 9 evenly. No. 472 by 3. Add the digits. 4 plus 7 plus 2. That's going to give me 13. 11 plus 2 is 13. And can I divide 13 by 3 evenly? Evenly. That means no remainder. Number 7, 174 by 3. Again, it's add the digits. 1 plus 7 plus 4, that's 12. I can divide 12 evenly. That goes in 4 times. So yes, that one is divisible. And number 8, 43,542. Okay, so we're going to do 4 plus 3 plus 5 plus 4 plus 2. 4 and 4 is 8 and 2 is 10. 3 and 5 is 8. 10 and 8 is 18. Is that evenly divided? Yes, it is 2 times. So my answer here is yes, that works. Oh. Okay. I'm lined up a little bit better. Okay, finding factors. All right, one integer is a factor of another if it divides that integer with a remainder of 0. So you can have numerous factors of a number. What ways can you multiply to get that number? Those numbers that you use, those integers that you use, they are your factors. Okay, so let's take a look at example 3. There are 20 choral students in the concert. Each row of students must have the same number of students. If there are at least 5 students in each row, what are all the possible arrangements? We are talking about what factors can we make out of the number 20. And we've done this before. We make what I call a factor U. So I write the number 20, I underline it. Start with a 1. 1 times 20 is 20. Go in order. 2, no skipping. 2 times 10 is 20. 3 doesn't divide in, so go to 4. 4 times 5 is 20. The next number I would try is 5. Oh, it's already there on this side. Once you get to a number that is on the other side, stop and you're done. Draw your U. So what combinations could I have? Remember, we must have at least 5 students in each row. I could do 1 row with 20, 2 rows of 10, 4 rows of 5. I could reverse these and say 5 rows of 4, but I don't have at least 5. Likewise, I can't say 10 rows of 2 because there was that one restriction on there. I must have at least 5 students in each row. So list all the positive factors of each number. Okay, underline it. 10, well, 1 times 10 is 10. 2 times 5 is 10. 3, no. 4, no. 5 is already there. You're done. So your factors are, go in order from the top of your U and read going down. 1, 2, 5, and 10. Number 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6. Next number I would try is 5, but it's not divisible. Next one would be 6, but it's already there. So my factors are in order from least to greatest. 1, 2, 3, 4, 6, 8, 12, and 24. Look at the number 36. Okay, we have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 is not divisible, 6 and 6. Now, this time, once, as I was going around, I would say, okay, stop when you get to a number that's on the other side of the U. However, unless you have a snake eyes, double, okay, you stop there as well. So now my factors are 1, 2, 3, 4, 6, 9, and we don't count it twice, 12, 18, and 36. And finally, the last one, 31. Well, the only way to get to 31 is 1 times 31. All right, that's called a prime number. These are composite numbers. Prime number has only 1 in itself for factors. Composite numbers, if you can find any other combination to get to that number, it's composite. 1 in itself is a prime number. And that's it. Good luck.